So this session is totally related to questions from acid, alkali, and salt, topic 8. The first one, which statements are the properties of the acid? So we have to check. The first statement is react with ammonium salt to form ammonia. That is wrong, because this is not the property of acid, this is a property of alkali. So it cannot be one. Red litmus turned blue. Again, red litmus turned blue. This is also a property of alkali. It is not a property of acid. So the first one is not a property of acid. The second one is not a property of acid. That is why the correct answer here is D. Because as what are the properties or characteristic of the acid? Acid can react with metal. Acid can react with metal oxide. Acid can react with metal hydroxide. And acid can react with metal carbonate. These are the reactions which we already discussed. And what about the effect on the litmus paper? When we add an acid, acid will turn blue litmus red. But in this question, they mention it turned red litmus blue. So that is not the property of acid. So 1 and 2 are not the properties of acid. That's why D is the right answer. Is it clear? The first question. Anyone having a doubt? The first one. The first question is, which statement are properties of acid? Like what acid do? So what acid do? The first property is written, acid react with ammonium salt to give ammonia. That is wrong, because this is not a property of acid. This is a property of alkali. Alkali turn red, and alkali can react with ammonium salt to give off ammonia. Acid cannot. Acid can react with metal, metal carbonate, metal oxide, or metal hydroxide. And the second one, when acid is added, they mention red litmus turned blue. That is also wrong. Acid don't turn red litmus blue. Basically, alkali turned red litmus blue. Acid, if acid was there, it will turn blue litmus red. So first one is not the property of acid. The second one is not the property of acid. So both are not the properties of acid. That's why D is the right answer. Is it clear now? The second one, which row describe whether amphoteric? Amphoteric oxide means they can react with acid and they can react with base. Like amphoteric oxides are having a dual nature, means they can react with acid, they can react with base. So can it react with acid? Yes, amphoteric oxide can react with acid. Can it react with base? Yes, it can react with base. So what is the right option? D is the right option, because we have four types of oxides: acidic oxide, basic oxide, amphoteric oxide, and neutral oxides. Oxide means a compound which contain oxygen. So acidic oxide can react with base. Basic oxide can react with acid. Amphoteric oxide can react with both. And neutral oxide, they don't have any reaction. The third one is actually related to the manufacture or preparation of the salt. In this question, which substance react with dilute sulfuric acid to form a salt that can be removed from the reaction mixture by filtration? So basically what we want to form, because if we want to remove a salt by filtration, so it means the salt which is formed here should be insoluble salt. Because insoluble salt can be removed by filtration when they are produced. So number one, barium chloride. So if we mix barium chloride We have barium chloride. Barium is group 2, chlorine is group 7. So barium chloride will be BaCl2. And sulfuric acid is H2SO4. So when barium chloride mixes with sulfuric acid, what it will form? Barium will take possession of hydrogen, and hydrogen is there in place of barium. So it will form hydrogen and chlorine, so hydrogen chloride. And what is the formula? When hydrogen and chlorine are together, so hydrogen is group 1, that is why plus 1, and chlorine is group 7, so minus 1. So formula of hydrogen chloride, HCl, will be like this. Plus, when barium take position of hydrogen, it will form barium sulfate. So barium is plus 2 and sulfate is minus 2. We simplify the valency. So barium sulfate formula will be BaSO4. So it will be BaSO4. Now when we check the salt which is formed here, because this is acid and this one is a salt. So we want to check whether the salt which is formed here is soluble or insoluble. So you have to recall that table when we discussed that all nitrates are soluble. Most sulfates are also soluble except three insoluble sulfates are. The three insoluble sulfate is barium sulfate, lead sulfate, and calcium sulfate. So these are the three insoluble sulfate, the sulfate salts which does not dissolve. So in the question, they mention which substance react with sulfuric acid to form a salt, and that salt must be removed by filtration, because by filtration we can remove insoluble salt. So when we mix barium chloride with sulfuric acid, it will form barium sulfate, and as we know barium sulfate is insoluble. That's why A is the right answer. Is it clear? Discussion 3, that why we select A, because when barium chloride is reacting with sulfuric acid, barium sulfate is formed, and barium sulfate is insoluble salt, a salt which does not dissolve. And when the salt does not dissolve, it can be separated from the mixture by filtration. If it was a soluble salt, then either evaporation or crystallization can be used to separate these salts. Are soluble. So next is silver chloride dimension. It is insoluble salt. Insoluble salt means does not dissolve, and it is prepared by precipitation. Which two substances can be used to make a silver salt? So we want to make a silver salt or silver chloride. So we want to produce a silver chloride. If we check the first option for question 4, barium chloride plus silver nitrate. So when barium chloride is mixed with silver nitrate, what will happen? The barium will take possession of silver and silver will take possession of barium. So as a result, what they will form? They will form silver chloride. Silver is plus 1 and chlorine is group 7 minus 1. So silver chloride will be AgCl plus barium nitrate. The formula for barium nitrate, barium is plus 2 and nitrate is minus 1. So barium nitrate will be BaNO3 in a bracket 2. So as you can see, when we mix the two solutions together, as a result, what it form? It will form silver chloride. And this is called a precipitation reaction. In a precipitation reaction, we should mix two soluble substances, two aqueous substances. So most chlorides are soluble except silver, mercury, and lead. So this is a soluble, barium chloride is soluble or solution. All nitrates are soluble, or all nitrates, they can make a salt solution. So when we mix two salt solution, and most chlorides are insoluble except silver, mercury, and lead. So this will be insoluble. So when we mix two insoluble solutions to form an insoluble salt, we call that as precipitation. That's why for this one, A is the right answer. So we don't have to bother about the other option, because the idea is that we should mix two solutions to form a solid we call precipitation. Why B cannot be? Because hydrochloric acid is aqueous, means solution, but silver is a metal. So this is a solution, but silver is a metal, so it will be solid. So that's why B cannot be. When we check hydrochloric acid, it is aqueous or solution, but silver bromide, silver iodide, these all are insoluble salt, does not dissolve, so it cannot be used. Same thing, sodium chloride plus silver iodide, again, silver iodide, silver bromide, silver chloride, these all are insoluble salt, so we cannot use this technique. That's why A is the right answer. So whenever we are preparing a salt by precipitation, we should mix two solutions. And how to identify that two solutions are there? You have to recall the table in which we discussed the soluble and insoluble salts. So mixing two solutions, as a result insoluble salt is formed. We call that as precipitation. Then another question related to precipitation. Barium sulfate is insoluble. So it is an insoluble salt, and how insoluble salts are formed? Insoluble salts are formed when the salt solutions are mixed with each other. So aqueous copper sulfate mixed with aqueous barium nitrate give copper nitrate and barium sulfate. So you can see a solid. So when two solutions, aqueous means solution. So when two solutions are mixed together and form a solid, this solid is known as precipitate, or we can write PPT. So what is the correct order of steps to obtain a pure dry sample of barium sulfate? So first what we should do, we will mix the two solutions in a test tube. One test tube, we have copper sulfate solution, and the other test tube, we have barium nitrate, the second salt solution. Both are solutions, and as a result, when we mix them together, what it will form? It will form a PPT or precipitate. So when we mix them together, it will be solution and some solid will be there, and that is PPT, which is barium sulfate. So how we can remove this barium sulfate, like insoluble salt? So first what we should do, whenever we want to remove the insoluble salt from the mixture, so first step should be filtration. So all step one is filtration. Then what we do, the solid which we have now after filtration, we wash that solid with the distilled water, because that is insoluble, that does not dissolve. That's why we can use a, you can simply wash it with the water. So second thing is wash, and the third thing you will dry. This is how the three main steps to obtain the insoluble salt. First filter, then wash the substance, the thing which is left on the filter paper, that is the residue, and then dry the residue. So what is the correct order? Filtration, that is, then wash, and then leave it to dry, or you can use a filter paper or a tissue paper, or desiccator is also used to dry the substance. Is it clear? Discussion 5, that how we can obtain an insoluble salt from the mixture. Any doubt till this point? Again, an amphoteric oxide. What is the meaning of amphoteric oxide? Amphoteric oxide means it can react with acid, it can react with base. So amphoteric oxide can react with acid, it can react with base. Or alkali we can also say. So if we react hydrochloric acid, because zinc is amphoteric, so yes, there will be a reaction. If we react with aqueous sodium hydroxide or a base, yes, there will be a reaction. So both cases, the reaction will occur. That is why A is the right answer. So amphoteric oxides can react with both. If it was a neutral oxide, then it does not react with acid or alkali. So there will be no reaction with any of them. It is an amphoteric oxide. The term amphoteric means it can have reaction with both. So hydrochloric acid, this is acid. And when hydroxide is there, what is the meaning of hydroxide? It means this is a base. So aqueous sodium hydroxide, which is a base. So yes, there will be a reaction, and acid is there, there will be a reaction. So whenever you have hydroxide, it refers to a base. That's why it can react with both of them. Is it clear, this question 6? So if you want to identify whether a substance is alkali, if it is hydroxide, then it means it is an alkali. In question 7, which row shows how the hydrogen ion concentration and the pH of ethanoic acid compared with hydrochloric acid? So ethanoic acid is a weak acid, and hydrochloric acid is a strong acid. And weak acid, as we know the definition, acids are proton donors. That is a definition for acid. They donate proton, or they give H plus ion. And acid can be categorized as weak or strong. The term strong acid means it gives more hydrogen ion, and the term weak acid means it give less, it give hydrogen ion, but for a strong acid it is giving more hydrogen ion in the solution. Weak acid is giving less hydrogen ion. So first thing, if we compare ethanoic acid with hydrochloric acid, so ethanoic acid is a weak acid. So if it's a weak acid, the number of or amount of hydrogen ion will be lower. So either C will be answer or D. Then what about the pH? As we know, the pH scale ranges from 0 to 14. The starting of the pH scale is 0, and at 14, the 7 is a neutral. Then we have 6, 5, 4, 3, 2, 1. And then we have 8, 9, 10, 11, 12, 13. So when we compare, like, two substances are there, pH 1 and pH 3. So which is strong? The one which is having a pH 1, that will be stronger. So strong acid have a pH 1 to 2, and weak acid have a pH from 3 to 5, or 3 to 6 you can also say. So when we compare the pH of the weak acids, the pH of the weak acid is higher, like it will be more as compared to a pH of strong acid. So pH will be lower for, ethanoic acid pH will be higher. Ethanoic acid is a weak acid, so its pH will be higher, but the amount of hydrogen ion concentration will be lower. That is why C will be the right answer. Is it clear? Question 7, why C is the right answer? In question 7, a pure sample of insoluble salt. So we want to prepare insoluble salt, barium carbonate. Can be made by using a method given. So method is given. First we take barium chloride in water, then we take sodium carbonate, So first we have like a solution of barium chloride, and that is mixed with sodium carbonate. So if barium chloride mixed with sodium carbonate, what will be the result? What will be the product? So there will be a displacement reaction, double displacement. Barium will take position of sodium and sodium will take position of barium. So what will be the result? When two solutions are mixed together, salt solution, as a result, it will form sodium chloride plus barium carbonate. So, and this barium carbonate is insoluble, so we call that as a precipitation. As we have the solution here, this one is a solution, this is also a solution, this is a solution, but here barium, most carbonates are insoluble. That's why barium carbonate is also insoluble. So when we mix two solution, a solid is formed, we call that as precipitate. So first we make the two solutions, step 1 and 2, then we mix the two solutions, then we filter. After filtration, because once we filter we'll get barium carbonate, but after filtration what we should do? What is the step 5? Which instruction is missing here? So after filtration we should wash them with the distilled water. So wash the residue with the distilled water, and then we will dry by using a filter paper or a tissue paper. So whenever you are preparing insoluble salt, mix the two solutions, then filter to remove the salt out, and after filtration you will wash and dry by using a tissue paper or a filter paper. Is it clear? Question 8. Any doubt in this? The next is which type of oxide aluminum is. So as I told you when we were discussing the type of oxide, I told you just learn the examples of amphoteric and neutral. So what are the three amphoteric oxide which you have to learn? The examples. The three amphoteric oxides, the example which you have to learn, that is zinc oxide is amphoteric, lead oxide is amphoteric, and aluminum oxide is also amphoteric. Amphoteric means they can react with both acid and base. And the neutral one, carbon monoxide, is a neutral one. So it is not acidic, it is not basic, it is not neutral. So we are left with option B. So these examples, it's important that you learn these examples. So without hindrance, you can simply answer the question related to examples. In question 10, which statement about weak acid? So weak acid such as ethanoic acid are correct. All the acid, even it's a strong acid or weak acid, all the acid can react with carbonate. So it does not depend on what kind of acid is. Strong acid react faster, weak acid reacts slower, but all of the acid can react with carbonate. That's true. It does not neutralize sodium hydroxide. That is wrong. All the acid, even strong or weak, can neutralize or can react with base. So this is wrong, because here it is written it does not, but in practical all the acid, even strong or weak, can neutralize an alkali or can react with hydroxides or alkali. Acid turn red litmus blue, that's wrong. This is not the acid turn blue litmus red, but here it is written red litmus blue. That's why 3 is also wrong. And it only partially ionized. What is the meaning of partially ionized? Like it gives less ions, and that is true, because that is a definition of a weak acid. That weak acid, they give few hydrogen ions in the solution or less hydrogen ion in the solution. So that is the right answer. means right option. So we have one statement 1 and statement 4 are the correct. That is why B is the right answer. Is it clear? That statement 1 and statement 4 are the right one. Then we are preparing insoluble salts. We can see there are a lot of questions. Even within 11 questions, there were 4 to 5 questions related to making insoluble salt. So we want to prepare silver chloride, which is insoluble in water. Which statement describe how a sample of silver chloride can be made? So how we can prepare silver chloride? When we check the options here, if we mix, because this is insoluble salt, if I cancel out the wrong options, I easily identify the right one. Look, if it is an insoluble salt are obtained by filtration. We'll always filter. So in option B, it is written evaporation and crystallization. That is wrong. In option C, it is written evaporate and crystallize. That is also wrong. So we are left with A and D. So A can be answer or D. Now we have to check whether A can be answer or D can be answer. But when insoluble salts are prepared, they are prepared when solutions are mixed. But when you check option D, add silver. So silver is a metal. It is not a solution. It is a solid. So solid mixed with acid does not. This is not the technique to prepare insoluble salt. Insoluble salts are prepared by mixing two solutions. So we have aqueous silver nitrate and we mix with sodium chloride. So when we mix silver nitrate with sodium chloride, so as a result, what it will give, again the displacement, double displacement reaction occur when two salt solutions or two solutions are mixed together. So silver will take position of sodium and sodium will take position of silver. So as a result, the product will be sodium nitrate plus silver chloride. So sodium nitrate plus silver chloride will be the product. And this silver chloride is insoluble salt. And what we can do when it is formed, we can just filter, then wash the residue. So D is not the right answer because in D we add silver metal. But A, because we mix the two solutions and insoluble salt is formed, we can just filter it off and then dry, wash and then dry. Is it clear? Question 11. Then question 12. Amphoteric oxide, again, it's a straightforward question. And amphoteric oxide means which can react with both acid and alkali. So metal oxide like calcium oxide or metal oxide is called basic oxide. Sodium oxide is a metal oxide also called basic. Sulfur dioxide is a non-metal oxide called acidic oxide. Whereas aluminium, zinc and lead, these are the three options which you have to learn as an amphoteric oxide. Amphoteric oxide means can react with acid or alkali. Now, chloric acid HClO is formed when chlorine is dissolved in water. It is a weak acid. What is meant by the term weak acid? What is the definition of weak acid? First thing, what are acids? Acids are proton donors. So this will donate proton or this will give proton in the solution. So it contains few hydrogen atom. Why this statement is wrong? Because this is not it should not be hydrogen atom, it should be hydrogen ions. or H plus ions. But here they mention hydrogen atom, that's why A is not the right answer. It can easily neutralize. That is not the definition for strong. It easily neutralized depends on the amount of acid, but it does not depends on the nature, whether it is a strong or weak. That's why it cannot be an answer. It is less concentrated. The concentration means the concentration depends on us. Like we can have a weak acid, but it is concentrated, because the term concentrated means when we say it is concentrated, it means it has less water. And when we say it is dilute, it means it has more water. So amount of water will vary or change. So acid concentrated, a weak acid can be a concentrated, can be a dilute. So it's not necessary that it is less concentrated. It can be more concentrated. That does not explain the weak acid. So the last option, it only ionizes partially, or it, that is right, because it ionizes partially or break down. The term ionization means breakdown of the molecule. So the molecule breakdown, few molecules will break down into ions. We call that as ionization. So it is partially ionized, it will have few hydrogen ion, and as it has few hydrogen ion, it will refers to a weak acid. So this is always the definition. Even in a structure question they ask, define the term weak acid. So you will say they ionize or dissociate partially. Silver nitrate react with sodium chloride to produce silver chloride. So what is this silver chloride? This silver chloride is insoluble. Most chlorides are soluble except silver, mercury and lead. So this is an insoluble salt. And if we want to prepare insoluble salt, so which technique can be used? Directly filtration, because the salt which is formed here is in a solid state, and we can just pass the mixture through a filter paper and the salt will be separated. In question 15, germanium is a white powder, and they mention here germanium react with germanium oxide is a white powder. Germanium oxide react with acid. So it is reacting with acid. It is reacting with sodium hydroxide. So base is so hydroxide or base. And it does not dissolve in water. So it is insoluble in water. What kind of oxide is this? The oxide which can react with acid, which can react with base and does not dissolve in water. What we call that as amphoteric oxide. So the term amphoteric oxide refers to that it can react with both acid and alkali. These are the characteristics of amphoteric oxides. The hydrogen chloride gas react with water to produce acidic solution. The equation is shown. HCl plus H2O gives Cl minus and H3O plus. Which statement describe what happened during the reaction? So what happened during the reaction? HCl donate proton and H2O accept proton, because like first we were having HCl, then it turned to Cl, and first we were having H2O, then it turned into H3O. So it means HCl donate or give out proton and H2O accept proton. So when we check this statement, chloride ion is formed by accepting the electron from water. That is wrong. Chloride ions are formed because HCl is donating proton. Here it's written donating, accepting an electron. That's wrong. The hydrogen chloride, the hydrogen chloride loses electron. That is wrong. It is the hydrogen chloride or HCl is not losing electron. It is losing H plus, and H plus means proton. Water accept proton to form hydrogen chloride from the hydrogen chloride. So what happened to water? Water is H2O, and you can clearly see like water is taking proton, or water is H2O, it turned into H3O. So when we check the change here, Initially it is H2O, then it turned into H3O. So H2O turned into H3O. What it shows? It shows it accept proton. And from where it accept proton? It accept proton from HCl. That's why C is the right answer. Is it clear? This question, like why water here in this example, according to the equation, the water is accepting proton or H plus ion. Is it clear? Any doubt till this point?